All right, let's do the last two. Now, it says name the element described. So 5p4, so we all know that p starts with 2. So 2, 3, 4, 5. 5p4 would be 1, 2, 3, 4. So tellurium, Te, that's going to be your 5p4. That's it. Tell. Okay, so Te, that's your answer. Easy. Next, quantum numbers. Y'all so excited. So name the element described. So we have to name an element based off of this. Automatically, these two should be easy, okay? You can tell the first two from these. All right, so basically we're going to, from this, we're going to find this, and then we can identify it that way. So from this, we know it's already in the 5 principal energy level, 5th principal energy level. 2, so again, that's the L quantum number, and if it is 0, it's an S. If it's 1, it's a P. If it's 2, it's a D. And if it's 3, it's F. So in this case, it's 2, so we know it's D. So it's 5D. Okay? I know that's... I'm tired. All right, so 5D. Now, to find out the number of electrons, so we know it's going to be 5D. So we know it's going to be, this is 3, 4. So we know it's one of these guys, right? It's in the 5D column. So 5D, so we're going to look at this and this to find out what the electron is here. So we are going to, we know D has 5 sublevels, 4, 5. If you don't know that, you may want to have a study partner. So 5D, and these numbers will range between negative L and positive L. Okay, so negative L and positive L, so it's negative 2, negative 1, 0, plus 1, plus 2. Now we're going to go, so 0 represents this thing. Okay, that's M sub L. Okay, so that's 0, and we know that here. So we know that whatever this electron is that's supposed to go up here is going to land in that 0 orientation. So then we know that it's going to be the electron that's not pointed up but is pointed down, and we know that because of the negative charge right there. So we're going to fill up this with our electrons using the rules we're supposed to use until we have a down arrow in the 0 orientation. So 1, 2, 3, 4, 5, 6, 7, and we're there, 8. Okay, so that ends up being 5D8. Okay, now the main question kids had, most of you guys are okay with this. So we need to find the element that's 5D8. So you guys are like, well, do I count this? Do I not count this? What am I supposed to do? So 5D8, so you do count this. So it's 1, 2, 3, 4, 5, 6, 7, 8. So the answer is platinum. Okay, so there's your answer. Okay, that's how you find that. So it was basically this, but we had to find this first with that. These are quantum numbers. All right, write the 4 quantum numbers for the following. Sn. So Sn, I find it. Where is it? It's probably right in my nose. Sn, oh yeah, that's 10. Okay, Sn is in the 2, 3, 4, 5th. So it's 5p2 is Sn. Okay, 5p2. Whoops, sorry. Much further down than I thought. Hold on, there's something under my paper and it's going to bug me. Anyways, okay, so 5p2 is what I said, right? 5p2. Okay, so 5p2. We need to write the 4 quantum numbers. 4 quantum numbers consist of n, l, m sub l, and m sub s. Okay, so n, that's super easy. It's 5, and that's because of this thing. Okay, L, that's super easy. It's P, so same rules apply. So P is equal to 1. So L is equal to 1 because it's a P orbital. Now, from this, we usually find these two together. So the P orbital has 3 sublevels. They're going to range from negative L to positive L, which is negative 1 to positive 1. Then we're going to use these electrons and find our spins. So 2 electrons. So you just fill it up until you have used all of your electrons, and that will be 2. So it's 1, 2. So that is 2 electrons. So our last, so 5p2. So this is 5p1. This is 5p2. Okay, if there was 5p3, it'd be here. 5p4 would be the one facing down. 5p5 would be this one, and 5p6. We're looking for 5p2. That is here in the 0 orientation. So that's going to be 0. And the spin is spinning upwards, so it's going to be plus 1/2. It could only be plus or minus 1/2, so that 50-50. So I just kind of messed up. That's the electron configuration of the neutral. So how I like to solve chlorine, okay? The chloride ion. So first I like to do the neutral, what's it called? The neutral electron configuration, which is 1s2, 2s2, 2p6, 3s2, 3p5. So that's neutral. So the chloride ion, okay, we're going to add an electron here. So then it becomes 1s2, 2s2, 2p6, 3s2, 3p6. So now we're just going to look, and we need to find the quantum numbers, right? M sub L, M sub S. Okay, so N, that's very easy. So we're looking at this one for the chloride ion, okay? So from here, obviously we know N is 3 because of this. P over here, P is 1. So L is going to equal 1. M sub L, so P has 3, so it's going to, M sub L will either be -1, 0, or 1, depending on which one the electron falls on. We have 6 electrons, so it will fill it up. 1, 2, 3, 4, 5, 6. So that 6th electron is in the positive 1 orientation. It's pointed down, so it will be in the -1/2 spin. So that's our answer for that. Sorry, I kind of got crazy at the end. I'm tired. I tried to do this one theoretically, didn't work, just to see if maybe they wanted it theoretical, but even that one, there's nothing paired with anything. So good luck on your test. Yeah.